So, hi everyone. My name is Igor Samokysh, and I'm working as a test automation engineer mostly at a company called Visma Labs. We're located in Riga, Latvia, but I'm from Ukraine. Today, I will speak about performance testing, and particularly about performance testing in web application. Here is a picture of a kitchen. And every 2 weeks in Riga, I'm coming to Riga Central Market to buy a lot of food. And then when I come back to my home, I'm very happy that I have so many shelves in that kitchen that I can really put in that food inside that kitchen. You may wonder now probably why I'm telling you this. And first, because I think that performance testing is a lot of other IT stuff can be related not only to really IT stuff, but to also other things like kitchen or parking lot. And second, and the most important part, is that I want you to create an analogy with this kitchen to learn what I will talk today more easier and, of course, better. One question, anyone familiar with such a learning technique called memory palace? Okay, a few hands. So for those of you folks who are not, it's a learning techniques that helps you memorize learning material better by associating those learning things, those things that you're learning, with something inside very, very familiar physical location. And today we'll use this kitchen. I hope kitchen is very familiar physical location for everyone. Before I start, I have another question. Anyone familiar with web-based application? Super, almost everyone. Web-based application. Yeah, super. So just a brief overview. Basically, web-based application is a kind of application which consists of two main parts: client, our PC, and the server, another probably big PC. And when, for example, you log into Amazon, you're sending requests to Amazon server, and server gives you a response. And this request and response, these things is quite important today to know, because I will talk about them quite a lot. And we will, well, basically, one way to measure performance is to check how fast response from the server are. Super. So I remember when I first was asked from my manager to do performance testing on web application, what I did is I Googled a bit. I found one tool, it was JMeter. I read a bit documentation about it and start to write in basically a script in JMeter and attack our test server, hopefully, with those scripts. And at that particular moment, I was feeling that something I was doing a bit wrong, really, by doing like that. I'm not saying that it's totally wrong. Sometimes it can work out when you need to test performance. You just get a tool, emulate a few APIs, a few requests, measure that your application can hold 500 simultaneous users, then it's enough. But at that moment, I was thinking something I am missing. And what I was missing is some methodology, some coherent way of doing performance testing for web application. And here you see 7 steps for doing that methodology for performance testing. We'll start with first activity named Identify Test Environment. And as I mentioned, Memory Palace, learning technique to remember things a bit easier and better. So my analogy for this activity will be a kitchen itself. And why? Because to test any kitchen, we need some test kitchen, obviously. One more question. Colleagues, how environments environments do you usually have on your project? And now, in my case, it was from 2 to 3. 7, 10, 2, 5, more. 7. I was hoping for that amount. Yeah. So, from my experience, usually in project, we had at least two environments, test environment and production environment. Sometimes we have more, like stage environment or some other stuff. But what is the main essence of activity number 1 to identify a test environment is to completely understand differences and similarities between your test environment and your production environment. And you can do this by checking these 3 key characteristics. First is hardware resources, software, and test data. Hardware resources is your CPU, your RAM, your memory, either it's HDD or SSD. Then we go to software, particularly for load balancer and for some anti-malware and anti-malware software. And test data, quite obvious. The bigger size of database, the slower it becomes to request information from it. And here is a simple screenshot that we did at one of a project for doing analysis of test environment. So at that time we had 3 environments, acceptance, stage, and production. And what we did is we just took information of what amount of CPUs, what CPUs are, what RAM, amount of it, HDD, types of memory and CPU, and analyze what really are the differences. And even from a first look, it's quite obvious to spot the differences between acceptance and production. Acceptance is at least twice slower. And then hopefully we start to test performance on stage environment, and it was almost the same as production, hopefully. Only SQL Server number 2 had a bit different amount of CPU cores and RAM. This is needed actually to understand and create some weighting formula to understand your results on your test environment. When you've got 2 seconds on stage environment, you can more or less predict what will be a response time on production environment. And of course, if you test on acceptance environment and you got half of a second, probably on production it will be even a quarter of a second. So first activity, identify test environment. I want you to associate it with a kitchen itself. Why? Because, as I said, to test any kitchen, you need to have some test kitchen. And of course, you need to understand differences and similarities in case of hardware, software, and test data there. Second activity is identify performance acceptance criteria. And it's basically activity where you define what scenarios, what APIs or what set of APIs or what UI pages you will test against performance characteristics. And as usual, this activity I want you to associate with a dishwasher machine. This one. And why? Because let's imagine you trying to select a new dishwasher for your kitchen, and the first thing you will do is to check how fast the dishwasher washes, basically response time. Then you will check how much cups and plates it can wash, basically through output of it. And last but not least is how many water and chemical dishwasher use per one wash, let's say, and it's basically resource utilization. And the same happened when we tried to identify performance acceptance criteria. First, we are looking for thresholds or for some accepted response time. So we need to figure out what response time will be okay for us. Then what through output will be okay for us. How many users per 1 minute or per 1 hour we can hold. Resource utilization, the same. How much CPU and memory shall be used per 1,000 concurrent user. And how you can actually get those information. From my experience, it's getting insights from four main sources. It's your company or industry standards. Then some government requirements obligated by law. If you work in some aerospace industry, probably there is a lot. Collaboration with team members. Well, from my experience, it's the most commonly used, like collaboration with the team members, because they know quite a lot about customers. Product owners also know a lot of things. And then, of course, a common sense. in one article a few years ago, I think it was Forbes, I read that 1 in 4 1 in 4 user will abandon a web page if it took longer than 4 seconds to load. So basically, your first threshold as a response time can be a common sense of having 4 seconds. Here is a photo. Actually, it's a screenshot of one of our company standard for performance. So we're slowly moving from traditional system of having servers standalone in our side to DevOps, and this model in Visma called Visma Cloud Delivery Model. And in order to switch to cloud, each application should complete survey and some assessment. And there is a performance characteristic that any application should meet, and it's defined on a company level. So we are obligated basically to satisfy all requirements that our company have. And you can actually check if your company, of course, are quite big, if you have any of those. And if you have, you can actually use already predefined standards for performance as acceptance criteria. It's actually hard to see, but there is a few requirements called NFR. The first one for asynchronous APIs, which said that like 95% of APIs should complete within 10 seconds, and then there is another requirement which stated that page shouldn't load more than 2 seconds. Second activity, dishwasher. Why dishwasher? Because when we wanted to select a new one, we check those characteristics of dishwasher, so we will know which one to choose. Third activity is plan and design a test. And this activity I want you to associate with a fridge, or probably me looking into fridge. So why I choose this analogy? Before I start to cook any dish, what I do is I open fridge and look for products that are here. And after that, I'm sitting down and thinking and planning and designing what dish I can basically make out of those products. And usually I use these four commonly used products. So business critical product. For example, if I want to cook French fries, potato will be a business critical. I cannot do French fries without potato. Then we go into mostly commonly used. For example, if it's cake, it will be obviously sugar or some cacao. Then obligated by law, one of my friends have an allergy to honey, and if I cook for him as well, I'm actually forced to exclude honey. So I'm obligated by my friend to exclude honey from my dish. And then, of course, highly visible. For pasta, it will be a cheese. So in planning and designing a test, it's actually the same. You need to look into those usage scenarios for your application, not for food. And you need to select business critical scenarios. For example, if we speak about Vaze, navigation application, business critical scenario, I think it will be calculating a route, most probably. Then most commonly used scenarios of your application. Actually, this info can be extracted easily from any analytical tool if you have any. Hopefully you have. Google Analytics or AppDynamics works well. You can easily see by number of requests what those commonly used requests by your users. Then obligated by law, once more, if you are regulated somehow, your application regulated somehow by a law, you will inevitably have those things to check before ahead production. And then highly visible, just intent revealing what your user is see quite often. One thing that you should consider at this activity, at planning and designing a performance test script, is that each user have a bit different way of thinking before clicking. So each performance test script most probably will consist not only on one API call, it will be probably 2 or more. And the thing is that real user have a different delays between clicks, between basically calls to your server. And in top you see a graph which represents a static user delay. Dots are user activity, and the spaces between dots are delays between those activity. And you see that those spaces are evenly distributed through all users. And in order to achieve more realistic performance test results, you need to emulate those custom random delays, random syncing time for all of your simulated users in performance test script. And below you see normally distributed user delays, and it's quite easy to spot that those spaces are evenly distributed through all of your users. And this actually helps you to increase the realism of your performance test and performance test results. Particularly in JMeter, it can be done quite easily by just adding to a thread a timer. JMeter proposes you a bunch of timers. Each of them are well documented. Particularly, I remember I used a JSR223 timer, and yeah, it was quite easy to understand how it works and to add into your performance test script, at least in JMeter. So planning and designing a test as a third activity in doing performance test, I want you to associate with fridge. Why? Hope you remember. Fourth activity, configure test environment. And here is a coffee machine. Quite often, at least at the beginning when our office opened, it's actually a photo of our office kitchen, that coffee machine was having a lot of bugs. It was broken a lot of time, and a lot of people were arguing about the taste of coffee. So I saw a person who configures that machine quite often. I think once per week at least there was some man trying to do something in order to achieve better taste of a coffee. And that is why I want you to create association of configuring a test environment with the coffee machine. So, performance testing and configure test environment. I think this activity can be split into two sub-activities. First is to check your test environment, basically a place, environment or PC which you will attack, and then to check a place from where you will generate that attack, from where you will generate load. And in order to check a test environment configuration, I would suggest, it's not an exhausted list, but at least two things is a load balancer. You need to check if it is the same or at least similar, or at least understand difference between load balancer in production and what is the configuration of it. Sometimes you may even have a situation where you have load balancer in production and don't on your test environment. And second is a support team. Basically, check that you can reach someone from support, so that if something goes really wrong, like your test environment will break down, you will have a connection with someone who can fix it quite fast. To check configuration of environment from where you will generate a load, I would suggest actually to check that that PC that will basically generate a load is powerful enough to generate that load. I know in JMeter, at least for some standard PC with 4 gigabytes of RAM and 2 gigahertz of 2 CPU core, JMeter can do 2.5 threads per one PC. So if you're planning to have more, you most probably will need to extend your JMeter node to more PC. So check that one, that your PC will basically work out with your planned load. And I would say that this is the three main things you need to check at this activity: configure, test environment. And this activity goes to coffee machine analogy with this nice stuff. Activity number 5, called implement. Well, interestingly enough, that this activity is what most people envision when they hear word or phrase performance testing. They think that trying to download the tool, create a performance test script, and attack your server, it's what you basically need in order to do performance testing. But turns out that, at least based on this methodology, just only one activity. And I think that this activity is entirely tool specific. What I mean here is that whatever test you have planned and designed, implementation will be different in JMeter from implementation in Gatling. And the same will be different from Gatling to some IBM or probably Load UI. The one thing I want to mention in this activity is that you really should expect to spend quite significant amount of time at this activity. From my experience, when I first stepped up into this activity, just to emulate login, just to collect cookies from our application, it took me, I think, 2 or 3 working days just to do that in JMeter. It was quite complex authorization model in that application, so I think that is why it was quite hard to emulate that. But expect to spend really more time on this activity because you will, from the beginning, have problems with implementation. And yeah, this activity, you probably wonder where is the analogy. So imagine me trying to cook some dish, and it can be said in other words, I'm trying to implement a dish, and kitchen, I don't know how this is called, kitchen deck or kitchen, sorry? Okay, that name you all heard. So, or just use a cucumber if you want, as an analogy to activity number 5 to implement the dish. Basically, a place where you cut cucumber is our needed analogy. Activity number 6, which called execute test, I want you to associate with kitchen table, and why I will explain right now. So imagine I already cooked a dish that I've designed and planned, and now I want to basically execute it. Basically eat dish that I cooked. And how can I do that is, of course, I will put that dish on the kitchen table and will follow a few sub-activities or, yeah, sub-activities. First, I will notify my family that dish is already ready. Then smoke test of the dish itself, just check if it's not salty and ready already. Then begin a food execution, just eating your food. Reviewing the result, simply speak with your family if the taste is good. And of course, archive food, just simply hiding leftovers into fridge. And the same happens when we speak about execution of performance test script. First, we notify our team that we wanted to execute performance test at particular date. And no matter how far in advance you schedule your test, it's very good to notify, give some certain 5 minutes warning for all of your teams that you are going to execute some huge amount of load on a test environment. Then try to do a short smoke test of your performance test. How I'm doing this usually is I am reducing load of performance test script to, let's say, 1 thread and see if everything is okay, if test environment is still alive, if computer firmware load is generated also alive, if I'm receiving some responses and if I'm collecting any reports from tool I've selected. Then, of course, begin the test execution. For some tools, just a matter of just clicking a button. Reviewing results, and at this point, I want to say that it's not, it's not needed to review deeply results. From my point of view, at this sub-activity, you need to check that you got some results and they are at least somehow meaningful and reasonable, that you have some graphs, they are not empty or blank. And then you, of course, archive your results, performance test script, and if it's possible, a application itself. Here is a screenshot from Team City, one of our projects. So what we did basically is we implement a base performance smoke suite as a continuous integration. continuous integration job, and we have some small performance test suite. We added it to TeamCity. It uses JMeter. It executes on a TeamCity agent machine. And we basically are able to see all results in a time lapse. This build triggered 3 times per day, so we're able to compare results through day and through entire history of this build. So this is the one way how you can actually store your performance results, your performance test script. Of course, where you store performance test script is up to you. Well, SVN is, I think, quite nice things to use in this case. Analogy, a table where we basically implement, where we eat a dish. This goes to activity number 6, execute performance test script. Last but not least analogy, analyze, report, and retest. Another analogy, so here is boxes for sorted trash. And I hope that in our office it's not a butafory, and at the end of the day those trash goes to different boxes. But when I'm trying to sort trash, what I first do is I took into hand the trash that I want to throw. I analyze what it is, plastic or paper, and then I report that in my mind that it is a paper, for example, and throw it to a corresponding box. And I'm doing repeating, retesting, repeating the same with all leftover trash. So this is analogy to activity number 7. And obviously this activity consists of 3 main parts. It's analyze results. This is one example what results you can get from JMeter from the beginning, and quite hard to understand what is there. And by default you go just a plain text, but after, if you want to take picture, please. But after a bit of work, actually, you can force at least JMeter to generate a nice looking, but still for me old-fashioned graphs. And the only thing I want to mention with graphs is that, I want to mention 2 things. First is that it's the best way to understand and represent such information as performance test results. And second is that from the beginning, it will be quite hard to understand what those graphs really mean. For example, this one particularly shows a response time percentiles over time. And from the beginning, you will need to spend some time to understand those statistical and mathematical aspects of those graphs and what really it means. For example, percentiles, let's say 95 percentile, from business point of view means that 95% of your user will experience that particular response time. And if you see, let's take 90th percentile, it's red, and red one is below, it's above 2 seconds. So you can say that 90% of your user will experience response time for that particular API or scenario a bit more than 2 seconds. Then, of course, you need to report information. And from my experience, you need to report to 3 main type of people. It's technical team members, non-technical team members, and stakeholders. Before creating a report, you need to understand to which group you're going to report and what really they expect you to show them. And the few nice tools to create reports and show information is, of course, Grafana. Quite powerful tool to visualize all kinds of metrics, but still quite hard to integrate, at least with JMeter. But then, of course, if you will get used, it will be a bit easier. Then BlazeMeter, a freemium application which have a free account and, of course, not free account for a lot of users if you want. And particularly for JMeter, you can use a free tool for generate graphs like that. I don't, in our project right now, we're using Apache JMeter dashboard, and it's quite okay for us to see what is happening with performance. Before we were trying to integrate Grafana, but well, for us particularly, we didn't find a lot of time to investigate how how profitable it will be for our application. And of course, retesting. I think that performance testing is any kind of testing have its own regression cycle. So if developers or DevOps or infrastructure engineers change something related to performance, our practice shows that those changes can be very often negative in case of performance, and you basically need to retest your application against performance characteristics once more. And the one way to do that is, of course, to have a continuous integration job for that, at least for some business critical scenarios or for some mostly highly used scenarios. And yeah, at least we were able to implement JMeter into TeamCity. I think all other non-user interface performance tool can be implemented in the same way. And yeah, the last but not least activity to analyze, to report and retest your performance test is goes to boxes with assorted trash. So as we slowly moved to the end of this presentation, I want everyone or anyone from you to challenge yourself and to remember together with us all those activities by looking into this picture and to remember and recalling all those associations that you created. Don't be shy, I will help, or probably even the audience will help as well. So do you remember first activity? What it was associated with? With the kitchen itself. And its activity, what's the activity? Identify test environment. What was the second? Dishwasher, yes? And what it was about? Response time, how fast it was. Identify performance acceptance criteria, super. Then we slowly moved to what? To fridge, and I'm looking to some business critical products, highly visible product like sugar or honey for my friend. So it was activity to planning and designing a test. Then activity number 4 was coffee machine, super. And it was activity, I'm not hearing. Configuration of test environment and place from where you generate load. Then we slowly moved to eating our food. Where? At table. And it was execution of a test. Yes? What? Ah, super. So what it was? It was cucumber. Yeah. So what I skipped, it was analogy number 5. Yeah, and it was about implementation. And the analogies that we used was at kitchen stuff where you cut things. Okay. For me, it's cucumber. Table, execute a test, implement your dish, implement your test. Sorry, not execute, implement test. And last but not least, boxes for sorted trash, analyze the trash, report it as something, and doing the same for this. So this is basically the 7 main activities of, let's say, methodology for doing performance testing on web application. And I think it can work out not only with web application, but with any application you want to test against performance. And it is, for me at least, a coherent way for doing performance testing. At this point, I want you to thank you. And this is a barcode where you can find a Google form where you can leave a feedback for me. It's anonymous, so don't be shy to write some bad or good comments. Thank you once more. Hope you enjoyed.